Your next question, for $1 million, convert 89 base 10 to a number in base 2. Your options are 1101001, B, 1011001.
Welcome to today's class. Today will be our final class on number bases.
We are going to be learning to convert from one base to another, from base 2 to base 10, from base 10 to base 5, and so on and so forth. We are going to be taking some questions that will help us and guide us on how to go about solving any other question we might find on this topic in the future. All right? So I'm going to start by doing the basics. Let's take example 1. I want to convert 1001101 base 2 to base 10. Now what do? If you take a look at our first class on number bases, it's in the playlist. You can check the playlist. You find out that I said a little thing about place values, and that is exactly what we are going to be applying today. Number these according to place values. Say we have 1001101 base 2, and we have the place values to be, we start from 0, 0, 1, 2, 3, 4, 5, 6. So that we have 1 multiplied by this 1 multiplied by 2, the base, raised to power 6, plus 0 multiplied by 2 raised to power 5, plus 0 multiplied by 2 raised to power 4, plus 1 multiplied by 2 raised to power 3, plus 1 multiplied by 2 raised to power 2, plus 0 multiplied by 2 raised to power 1, plus 1 multiplied by 2 raised to power 0. How do we do this? Now we just solve this. We understand that this will become 1 multiplied by 2 raised to power 6 is 64, plus 0 times whatever this gives us is 0, so we don't need to rack our mind with that. So it's plus 0 plus 0 plus 2 raised to power 3 is 8, plus 1 times 8 plus 1 times 4 plus 0 plus 2 raised to power 0 is 1. Anything raised to power 0 is 1 except 0 itself. So plus 1 times 1. So this gives us 64 plus 8 plus 4 plus 1, which is equal to 77. I could write base 10, yeah? Or I could decide, I've mentioned it a lot of times, especially in our previous class, that base 10 is the natural base of numbers. So if you don't see a base there, just note that it's base 10. So I decide to not write it. All right? So that's that. That's how to convert from any base to base 10. Okay, it works for any base. We'll still see others as we proceed. Any base to base 10. But let's see how we can convert from base 10 back to another base. Now I'm going to try to convert 77 back to base 2. Watch this. So example 2, we are converting now 77 to base 2. Again, I didn't write base 10 here because you know already that is base 10 since there's no base there. We are calculating the natural base of numbers. So how do we do it? This is what we do. We say, it's on my line, 77 and 2. So we divide. We do the long division thing. So 77 divided by 2, that will give us 38, remainder 1. We're going to write the remainder there. We'll divide again. 38 divided by 2 will give us 19, remainder 0. There's no remainder. 19 divided by 2 is 9, remainder 1. 9 divided by 2 is 4, remainder 1. 4 divided by 2 is 2, remainder 0. 2 divided by 2 is 1, remainder 0. And 1 divided by 2 is 0. 2 cannot divide 1. So that's 0, remainder 1. So now what do? We write our answers upwards. We write our answers upward. The answer will become 1001101 base 2. That's just the basics of converting from one base to another, especially from base 10 to another. Usually, we cannot convert from one base to another base without going through base 10. How do I mean? Take, for example, we cannot convert from base 2 to base 3 without going through base 10. I'm going to give an example on that. Example 3. It says, if y is equal to 2, 3 base 5 plus 101 base 3, we have to find y, leaving our answer in base 2. How do we do that? These are two completely different bases. This is base 5, this is base 3. How do I do that now? What do? I convert this to base 10, right? Let's do that. Let's convert 2, 3, base 5 to base 10. We have 2, 3, base 5. We number it according to places, 0 and 1. So this becomes 2 multiplied by 5 raised to power 1 plus 3 multiplied by 5 raised to power 0. And this becomes 2 times 5, basically, that's 10, plus 3 times 1, anything raised to power 0 is 1, so that's 3, is equal to 13. So 2, 3 base 5 is 13 in base 10. You also convert these to base 10, 101 base 3, that becomes 0, 1, 2. So we have 1 times 3 raised to power 2 plus 0 times 3 raised to power 1 plus 1 times 3 raised to power 0. So we have 3 raised to power 2 is 9, 1 times 9 is 9 plus 0. We know that whatever we multiply by 0 is 0 plus 1 times 1, that's 10. So basically, y is equal to 13 plus 10, which is 23, but it is in base 10. So now we have to convert to base 2. So let's just do that somewhere around here. 23 to base 2. 2 in 23, that's 11, remainder 1. 2 in 11, that's 5, remainder 1. 2 in 5 is 2, remainder 1. 2 in 2 is 1, remainder 0. And 2 in 1 is 0, remainder 1. So 23 in base 2. Remember, we're writing upward, write upward. Don't forget that, write upward. Therefore, y is equal to 10111 base 2. I believe this is example 4. It says 110 base x is equal to 40 base 5. We have to find the value of x. Let's get into it. As I said, we have to convert the two of them to base 10. Okay? So we're going to be working on the right hand side as well as we're going to be working on the left hand side. So let's see that 110 base x is equal to 40 base 5. Let's call it 40 base 5. Let's give them their place value 0, 1, 2, and these will be 0, 1. Let's expand that. We have 1 times x raised to power 2 plus 1 times x raised to power 1 plus 0 times x raised to power 0 is equal to 4 times 5 raised to power 1 plus 0 times 5 raised to power 0. This becomes x squared. 1 times x squared is x squared plus 1 times x raised to power 1 is x squared plus x plus 0. Obviously, anything multiplied by 0 is 0 is equal to 4 times 5, which is 20 plus 0. So that is inconsequential. Now we have something that looks like a quadratic equation. We're going to bring this to the other side. You can see a square here, so it's a quadratic equation. Now we can do x squared plus x minus 20 is equal to 0. Now we solve quadratically. We're going to factorize. We have negative 20x squared after we multiply x squared by negative 20. Now we're looking for two numbers that we can multiply together to get negative 20x squared and add together to get x plus x here. And that will be 4 and 5. 4 and 5 will work. So we have 5x minus 4x. We are going to substitute these two numbers for x in the equation. So we then have x squared minus 4x plus 5x minus 20 is equal to 0. So we factorize now. We factorize. The common factor here is x into x minus 4 plus 5 into x minus 4 is equal to 0. So we have x plus 5, x minus 4 is equal to 0. In the very end, we are going to have x is equal to negative 5 or 4. Obviously, a number base, the base of numbers cannot be negative, right? You're going to agree with me that the base of a number cannot be negative. So in the very end, x will be equal to 4. Another example. We have 2 and 4 base 7 is equal to 1, 5, n base 9. We have to find the value of n. Find n. Right? As I said, the best way to go about it is to try to convert the 2 of n to base 10. I'm going to say 2 and 4 base 7 is equal to 1, 5, and base 9, 0, 1, 2, 0, 1, 2. We already know the drill. Let's do that. So we're going to do 2 multiplied by 7 raised to power 2 plus n multiplied by 7 raised to power 1 plus 4 multiplied by 7 raised to power 0 is equal to 1 multiplied by 9 raised to power 2 plus 5 multiplied by 9 plus n multiplied by 9 raised to power 0. This is going to give us, this is 2 times 49. Let me write it out for the sake of understanding. This will give us, this is 98 plus 7n plus 4 is equal to 81 plus 45 plus n. In mathematics, we collect like terms. So we're going to collect like terms. Let's bring all of the n's to the left hand side and bring all the constants, all the numbers that do not have n or anything, to the right hand side. So 98 and 4 are coming to this side while n is coming to this side. We're going to have 7n minus n will be equal to 81 plus 45 minus 98 minus 4. This becomes 6n, and all of this arithmetic is 24. Therefore, we are going to divide both sides by 6. We have 6 here, we have 6 here. We divide, n will be equal to 4. I believe that this lesson will guide you while you're trying to solve other questions that involve converting number bases from one base to another. If you have any question and you need help solving it, my WhatsApp link will be in the description. Thank you very much for coming to class today. Sunday, it's a pleasure to have you around. Bye bye.